So, the chain rule. Okay, now I'm going through a slow process with you here, but there's going to be I think it's quicker method just after. So, you get given this in the formula book. Okay? Now, the thing is, when do we use this chain rule? Chain rule is used if you are trying to differentiate essentially a function of a function. Okay? So where we've been looking at pretty straightforward expressions, if we were trying to differentiate something like this, okay, that's way more complicated. Agreed? And for a start, I definitely don't want to be expanding something to the fourth bracket. Even using binomial expansion, that's going to be a real pain in the bottom. So we don't want to be having to expand that, so we want to try and find a quick method. So if you have something more complicated, then you're going to be using the chain rule. Okay? So this is more complicated because I have an expression inside a bracket, and that's raised to a power. So what I'm going to do is I'm going to say, right, I'm going to pretend or say that this expression inside the bracket, I'm going to call it u. Okay, so I've said that u is 2x cubed plus 3x squared. And that means that y is now u to the power 4. Yes? Good. So all I've said is this is now called u. And so y is u to the power 4, not all of this garbage. Yeah? It's not garbage. Okay. Right, so we've got y equals u to the power 4 and u equals this. We can differentiate these two functions. Okay? Now what we're used to seeing is we write dy dx. Agreed? And that's only because we have an expression that starts with y and it involves x's. If I've got an expression y that involves u's, what do you think I'm going to write? dy du. Totally. Okay? So I'm going to write dy du. My derivative is going to be using the same method that we had before. So u to the power 4 would become what? Tres bien. Okay? U is 2x cubed plus 3x squared. So how am I going to differentiate this? I'm going to write what? Nice. Okay? And the method is as normal.
So that's 6x squared plus 6x.
Nice. Okay? Now what have I written? Alright, so we've got two expressions here. We've said that dy du is this, du dx is this. What we can say is that in order to find dy dx, we're going to, oh, does it say it in the formula? Yeah, in order to find dy dx, we're going to multiply these two things together. Okay, so this is from this formula. So dy dx is equal to dy du multiplied by du dx. And what kind of happens is, well, the bit easiest thing I say to do is essentially these things kind of cancel each other out. Yes, because you've got a du on both top and bottom, so they merge together. That's the way it's easiest to realise why this happens. So what I'm going to do is I'm going to multiply these bad boys. But I have an expression with a u in it still. Okay, so that's not going to be any good to me. So I need to replace that with the original function. So dy dx. Final answer is going to be 4 lots of what next. Cubed multiplied by 6x. Okay. Okay. So it was a matter of establishing what should be my u. rewriting my expression to say that so y is now in terms of u, differentiating those two things and multiplying them together. Okay. So it's not a hard process and you get given that. However, I think it's a little bit easier just to think, well, let's go back to the original question of y equals, what was it, 3x? No, 2x cubed. 2x cubed plus 3x squared to the power 4. Okay, so if I'm differentiating that, dy dx, I want you to, in your head, pretend that that's just a letter. So my power comes in front. And I take one off the power. And then you multiply by the derivative of what's inside the bracket. And that's it. That's how the chain rule works. What do you mean?
Multiply.
So you pretend that that's just a letter. Differentiate, so it's 4 lots of that to the power 3. And then you multiply by the derivative of what's inside.
Oh! Wait, okay.
Oh,
Why do you write that in words?
So you treat it as if it's a derivative.
I don't know.
I see. And then multiply it by the derivative function of brackets.
Yeah.
There's
no other way of saying it.
Wait, but, shut
I
up.
see.
When I look at this, it's just so long.
Well, right. Just like
So right what we just said, like all of those questions we just said. So pretend that the bracket is a letter. Now, like as I said, it's not you don't have to do this faster method. Okay, you can like write things out in terms of u, and you've got the formula there to remind you. I just personally think that that's what they do anyway. They're pretending that this is something else, differentiating it and then subbing it back in. I just think it just wastes a little bit of time by doing that. Let me pause it while I'm going to Okay, so we're trying to find dy dx. Wait a second, let me flip the page.
dy dx would equal.
So what do? We pretend that this is on its own.
So 5 bracket 2x minus 3 to the power of 4.
Multiply that by,
Multiply that by
what's the derivative of the thing in the bracket?
2x. Oh, wait, 2.
Wait. No, it's
It's just
2.
2, yes.
And now in this case, because you've just got this 5 here and you're just multiplying by 2, you would simplify that to be that. Now obviously that previous example was way too complicated to try and expand stuff, so you don't need to. But if you can do the simplification, then you should do. Okay? Nice, easy peasy. Next one, dy dx.
3 bracket x squared minus 3 x equal to 2. And then you have to times that by 1 x 1. Girl.
Wait, so look at the expression here, differentiate that.
That would make it 2. 2 plus 2x 2.
You're just shouting about that.
I'm waiting for you to write something.
I know, because I'm waiting for a confirmation. You're changing, picking and choosing. You need to know
No,
that.
you put that to 2x
plus 3.
plus 3. Thank you for
2, 2, 2, 2, 3, 2, and this one I would probably also expand maybe. 6x plus 9. But but not super essential. But these times anyway.
Oh, yeah.
I just expanded this and this.
But you put it in the opposite order.
I did 3 multiplied by that 2x plus 3 bracket. And what did we say was the rule when we have stuff like this?
That is 2 power minus 1.
We wouldn't separate this one because there's only one thing on the top. And what did you say?
The bottom is not 2 power minus 1.
Negative 2.
So first thing is rewrite this, baby. Okay, you see what's -2?
Yeah.
Okay, so I'm rewriting that first. Now I can differentiate. So how do I differentiate?
So basically, it's like
X, 3 power 6 minus 2, negative 3.
6 minus 2
Why?
power minus 3 times the bracket of 6 x 6 x. That's it.
6 x 3 power 5.
And then what happens is you will multiply that.